Number 34. In this question, we are given two equations. First equation is a second degree equation. And we are told that the graph of this equation on the xy plane intersects the second equation. No, second equation is just a line. No, y equals x. So 1, so I labeled this label 1. So I just put these are not in the question. So 1 intersects equation 2, no, this line, I labeled that 2 at 2 points. No? 1 point we are told is 0.0, the second point is a point, a comma a, no? I'm sorry, it's not 0.0, it's 0 comma 0, no? X coordinate, y coordinate. And the other point is a comma a. Note it has to be the same x and y value. Why? Because of our second equation, no? X always equals y here. Note what's happening here. One way to think about this is we can think about this as a system, no? Because these are the solutions, no? That means at these points, both of these equations are satisfied. But when does that happen? When we are solving a system, no? So we can treat these guys, these like the two of them, like a system of nonlinear equations, no? Because we have a second degree here, we have a first degree here. But that doesn't matter really. The way to solve it is always the same. To solve a system, we'll just either do substitution or elimination. Obviously, here we'll do it because it's not nonlinear, we'll do substitution. So if we wanted to solve this, we'll need to go by substitution, no? So let's start by plug 2 into 1. So that means wherever I see y, I'm just going to plug in x. So x equals 3x squared minus 14x. So this is simply I'm just plugging in y equals x, which is my first equation. This is my second equation. Okay, so from here we are going to solve for the x's that satisfy here. Note there are two x's, no, because it's second degree. Okay, so on the right side I'm going to take out an x, so that means 3x minus 14 in parentheses. So now I'm going to subtract x from both sides, so we get 0 here, and x, 3x minus 14 minus x. No? Now on the right side, I'm gonna take it into x parentheses. So then I'm gonna have 3x minus 14 minus 1. No? I'm taking into x parentheses. If I distribute it, I'm gonna get my first term, x times this, no, minus 1 times x minus x. Note this equals 0. If this is 0, I have two factors. No? That means either this is 0 or this is 0. No? Or both of them are 0 because we are looking for two solutions. So let's say x is 0 for this. Then one solution is going to be x is 0. If x is 0 by 2, y equals 0 by equation 2. Let's do it this way. First solution, then x is 0. Second solution, when this is the guy, and this is the case, no? 3x minus 14 minus 1 equals 0. Add 1 to both sides. We get 1. Add now 14 to both sides. 3x equals 15. Divide each side by 3. Both sides by 3. We get x equals 5. When x is 5, again, because this is the solution set. No, it has to satisfy all the equations in the system. So if x is 5, then y is 5 also by equation 2. So the second point is 5, 5. This is my second solution. My first solution is x0, y0, which is 0, 0. Going back to the question, we are told that one intersection point is 0, 0. Yeah, we got that. And the second point is AA. Well, we got 5, 5. So A must be 5. And that's our answer. Again, let's recap what we've done. On the xy space, the graph of this intersected the graph of this at 2 points. No? And we said we can treat this as a system and find the solution set of that system. No? Find those x's and the corresponding y values, and then from there move on and find the unknown a that we were asked. So the thing that I want to add at this as a last point is, note the SAT could give us these two equations, no, and then say here is a system, a nonlinear system, because this is second degree, this is just a line first degree, and solve for the solution set we would find, no. But now what they're saying is, on the xy space they intersect at these 2 points. Note those intersection points on the xy points is the solution set of the system. No, they are just asking the same question from one algebraic way, basically solve the system algebraically, where we do substitution, or if it's all linear, we also use elimination. Here they are asking it in a roundabout way, but it's the same question. They are saying, like, look at their graphs, no? The solution points will be their intersection points, no? Now they go and ask, like, they go and tell this graph, the graph of this intersects the graph of this on the xy space at these points, which is the solution set. I just wanted to emphasize that. That's a critical point. I think it's an important question because the SAT is giving a different scenario where we just apply the same solution. No, here's a system, we just apply substitution to solve for that. So we are done for this question.